In this video, I'm going to talk about reference angles and non-acute angles. So the first thing that I want to do is I just want to review what is a quadrantal angle. So these are angles in standard position whose terminal side lies on the x-axis or the y-axis, so like 90 degrees, 180 degrees, etc. So just to like visually remind you, so remember we always start here with our initial side and then we can swing up here. So this would be a quadrantal angle. So my terminal side lies on the y-axis, or I could swing over here and then my terminal side is on the x-axis or down here. So these are what make quadrantal angles. Okay, so those are quadrantal angles. Now, I want to go back to thinking about non-quadrantal angles, so things that are not those. With every non-quadrantal angle, we have what's known as a reference angle associated with it from standard position. So just to kind of review some of that, so I start with my initial side, and then maybe here's where my terminal side goes. So my reference angle can be created by choosing a point, on my terminal side, and I kind of construct this. This gives me a reference angle, and I get a reference angle no matter which quadrant I'm in. So if I go into, let's say, like I swing my terminal side to the second quadrant, so now I get a reference angle here, and so here would be my reference angle, okay? Or if I'm in the fourth quadrant, this would be my reference angle in this case. So that's the idea behind reference angles, and I'm going to show you how to use those in this video. So let's just jump right into it, and let's find the reference angle for each angle. So we just want to find the reference angle. So starting with 274 degrees, I would recommend, of course, that you draw something to help you kind of figure this out. Okay, so think about the quadrants. So for 274 degrees, so this is this first quadrant, second quadrant, third quadrant, fourth quadrant. 274 degrees is going to fall somewhere into the fourth quadrant, right? So this is where I want to have that terminal side. So I've got my initial side, and then I'm going to swing around to get to my terminal side. So what I'm going to do is I'm going to choose a point on my terminal side, and then I'm going to draw to the x-axis, and this creates my reference angle. So I can see the angle, but now the question is, what actually is the reference angle? So let's talk about that. So this little angle in here, that's what we're trying to get to. And going all the way around up to this point, this is 360 degrees. So if I started here and continue to swing all the way around, this would be 360 degrees. So my reference angle can be found by kind of using the quadrant. I'm going to show you like a shortcut to how to figure this out in a second. So I'm just going to explain this for now. So I am going to take 360 degrees, and I want to just figure out what's like the nearest reference angle to this. So I subtract off the 274 to get 86 degrees. That would be the reference angle in this case, 86 degrees. Okay, so just kind of showing you what this is. Like I said, I'll break this down a little bit more in a few minutes. Let's talk about 822 degrees. So in this case, you need a coterminal angle first. So anytime you're over 360 degrees, first you want to find the angle that is coterminal with it. So remember, with coterminal angles, so you might have one angle, and if I were to add 360 to it, so I make a full rotation from that point, I would get what's known as a coterminal angle. So 45 and 405 in this particular example would be considered coterminal. So let's just talk about then how do I find the coterminal angle in my example. Well, if I take 822 degrees and I subtract 360 degrees twice, so I'm looking for the smallest degree I can get under 360 by subtracting 360 degrees. So in doing that, I get 102 degrees. So that would be the angle that's coterminal. Okay, so this is not quite my reference angle. What I want to do is I want to find an angle that would actually fall somewhere in the first quadrant. So let me show you how to get to the reference angle. So once again, so we're going to come up with our little illustration here. And we think about, where does 102 degrees fall? First, second, third, or fourth quadrant. So I've got my little cheat sheet here, and so I can see that 102 degrees falls somewhere in the second quadrant, okay? So I've got my initial side, and I'm going to swing out here to get this 102 degree angle. So this would make 102 degrees. But what's known as my reference angle, I'm going to take a point on that terminal side, and this in here, this is going to be what my reference angle is. And so this is what I want to figure out. So to do that, I'm going to reference the degree measure here and take 180 minus 102. And what I would consider my reference angle in this case would be 78 degrees. That would be my reference angle. Now, I want to just tell you guys, for notation, we use theta and then like this little hash mark, so like theta prime, to indicate that we have a reference angle. And I realized that watching some of this, it's like, how do I know what subtraction to do? So I've got a little bit of a cheat sheet here to help you figure that out. So basically, when we try to create reference angles, we want to create an angle that's between 0 and 90 degrees. It's very handy to express things back in 90-degree angles. So if we're in the first quadrant, then you don't have to come up with a reference angle. But when you get out of the first quadrant, then you have to do some magic to create your reference angle. So in the second quadrant, so if you're between 90 degrees and 180 degrees, to figure out what the reference angle is you take 180 degrees minus theta. Then in the third quadrant, so if you're between 180 and 270, to figure out the reference angle in that case, the way you would do that is you would take theta minus 180 degrees. And then for the last one, you'll take, to get the reference angle, you take 360 degrees minus whatever your theta is. Now, in my previous video, we talked about the special angles, 30 degrees, 45 degrees, 60 degrees, and we went through this whole chart. And so I would say like leverage this information whenever possible. So what I want to do is I want to find the values of all 6 trig functions for 240 degrees. You'll notice that that is not in this chart. So what we're going to do is we're going to draw a reference and figure out the reference angle to do this. So this is going to take a little bit of work, but I'll show you everything. Okay, so for 240 degrees, I've got my initial side, and then 240 is going to be somewhere in the third quadrant. Okay, so here's my 240 degree angle. So what I want to do next is I want to create that reference angle. So to get the reference angle, using this like little cheat sheet that we just talked about. So I'm going to take theta minus 180. That's what I want to do. So, okay, so let me go back to doing that. So I'm going to take theta, which is 240 degrees, and subtract off 180. That's going to get me the reference angle here. So when I do that, I get that my theta prime is 60 degrees. Okay? So now that's the reference angle, but I have to think about what are the signs of my trig functions in the third quadrant. And we've talked about this. All students take calculus. So we're talking about in the third quadrant. So in the third quadrant, tangent and cotangent are the only 2 positive functions. So we want to keep that in mind when we are coming up with the values of our 6 trig functions, because we can actually just use this table, but we just have to modify it a little bit for what we know about the quadrant. So, okay, so using what I know about 60 degrees, so for sine and cosine, I need to make sure that I put a negative sign in front of those. Tangent and cotangent, those values are fine. And then for secant and cosecant, those also need to be negative. So I just want to kind of note those when I'm interpreting this so I can translate this for the third quadrant. Okay, so like I said, so sine and cosecant, these are both negatives. And so sine of 60 degrees is negative square root of 3, or sorry, sine of 240 degrees will be negative square root of 3 over 2. And then the cosecant will be negative 2 times the square root of 3 over 3. Okay, and then moving on to cosine. So cosine of 240 degrees will be negative 1/2, and then the secant will be negative 2. So again, you just have to make them negative. And then tangent and cotangent, those will both be positive. So that'll be square root of 3 and then square root of 3 over 3. And so just keep in mind here so that I used 240 degrees, not 60 degrees when I was actually writing these out. And then I just made the appropriate adjustments to my signs. So let's just talk about now how to find any non-quadrantal angle in 4 steps. So first, if your theta is greater than 360 degrees or if theta is less than 0 degrees, you want to find a coterminal angle by adding or subtracting 360 degrees to obtain an angle between 3 and 360 degrees. So if you're above, so if you are not between 0 and 360, make the necessary calculations to get your angle between 0 and 360 by adding or subtracting 360 degrees. Then find your reference angle. And so that's where I've got that little cheat sheet that I showed you guys. And then determine the trig values for that reference angle. So that's where you can kind of modify, and think about the positive or negatives that you need to for that particular reference angle. Double check your signs. Remember, all students take calculus. You can avoid errors by sketching the angle in standard position. This doesn't have to be a perfect sketch. It's just there to really help your brain. Okay, so let's try this together. So let's go ahead and do sine of negative 150 degrees. So notice that I'm going to have to first get this to be an angle between 0 and 360. So you know that I'm going to have to add 360 to this. So let's think about maybe first of all just where do we think that this angle should end up? Okay, I'm going to show you how. I'm going to show you two different ways to think about this, I guess. Let's do it like that. So let's talk about where would sine of negative 150 degrees show up. So normally this is the way that we think about this table, right, in terms of positive degrees. But I took a second to reverse the table or the graph, and just so that you could see how the negative degree measures work out. So negative 150 degrees ends up in the third quadrant. So would end up over here. So if I start with my initial side and then I swing out to my terminal side, this would be where my terminal side ends up, and then there's my reference angle. Okay, but what if I want to find an angle that's coterminal? My question is, do I still end up in the same quadrant? Because I should. So this is just kind of here to help you believe this, I guess. So if I take negative 150 degrees and then add 360 degrees to it, I get 210 degrees. Where does 210 land me? It still lands me in the third quadrant, right? So this is both negative 150 degrees and 210 degrees. They are one in the same. Okay, so now that I've figured out my coterminal angle, now let's talk about finding the reference angle. So to find my reference angle, since I know I'm in that third quadrant, I'm going to take that angle 210 minus 180 degrees, and that gives me 30 degrees. So my reference angle is going to be 30 degrees. And now what I have to do is I have to consider, being in the third quadrant, what are going to be the values of my trig values. So I need to think about sine of 30 degrees. So that's right here. But then I'm in the third quadrant. So in the third quadrant, I need to add a minus sign because I know sine in the third quadrant will end up being negative. So this will end up equaling negative 1/2. So there's a little bit of, it's a little tricky in some ways. So what I want you to do for cosine of negative 510 degrees, I want you to try this one totally on your own. So first find that angle that's coterminal, and then try to figure out the reference angle, and then see if you can figure out what the actual answer would be. And you can hit play when you're ready. Okay, so I've got negative 510 degrees. I now believe with coterminal angles what this is going to work out to. So I'm first just going to go ahead and find the angle that's coterminal. This ended up just being 210 degrees. So same situation, right? And okay, so I'm in the third quadrant. I know that my reference angle is going to be 30 degrees. So because we'd already figured that out, right? So now if I use this table, I've got that my cosine of 30 degrees is going to be square root of 3/2. And since I'm in the third quadrant, I know that it needs to be negative, right? So the answer in this case will be negative square root of 3/2. Okay, so now let's just talk about some other ways that these types of problems can present themselves. So let's talk about sine squared of 120 degrees plus cosine squared of 120 degrees. So remember that for those squared functions, the way that we want to think about them is it's that function squared, like so. So really what I want to focus on is just finding sine of 120 degrees and cosine of 120 degrees. So if I think about if I create like some reference angles and some visuals for this. So my 120 degrees would look like this, and here's how I'll create my reference angle. So to figure out what the reference angle is, I'm in the second quadrant, so I know that I can take 180 minus 120 degrees to get 60 degrees. And so now I can think about viewing sine and cosine. So if I come over here, so sine and cosine of 60 degrees. There they are, sine and cosine. Now I'm in the second quadrant. So if you think back to all students take calculus, what should I do, or how should I manipulate these values? Well, in this case, sine will stay positive and cosine will be negative. Okay, so that's how I can interpret these. So sine of 120 degrees will be square root of 3/2, and cosine of 120 degrees will come out to negative 1/2. And so now I can plug those into this equation, right? And I can just square those values. So like you see here, so this is supposed to be sine squared of 120 degrees and cosine squared of 120 degrees. So I just square the two values that I found from over here to get that this comes out to 3/4 and 1/4. And so that will just equal 4/4, which is 1. So now we've got our final answer. Okay, so I have more examples of the previous two sets of examples. So finding all 6 of the trig functions or doing some of those calculations. I have more example videos of that, so you can check those out. I want to go through a couple more examples in this video since this is a little bit of a longer video and I want to make sure I get through enough different types of examples. Okay, so the next one is find all values of theta if theta is in the interval from 0 to 360 degrees and has the function value cosine of theta equals square root of 3/2. Okay, so what is going on here? So in this case, we're kind of like reverse engineering the process. And the first thing that I want you to notice is that this value is positive. So what you want to think about here are, where are my values of cosine of theta? Where will those be positive? That would happen when I think of all students take calculus. That happens in either quadrants 1 or 4. So I'm looking for what values of theta will give me positive square root of 3/2. So there's going to be 2 values where this works. All right, so I'm going to be in the first quadrant and I have to figure out where I get cosine of theta equals square root of 3/2. And then I need to rotate all the way into the fourth quadrant to figure out, again, where I get cosine of theta equals square root of 3/2. So I can use this chart to help me figure that out. So where do I get that cosine of theta equals square root of 3/2? That occurs here at this point. So that is at 30 degrees. Cosine of 30 degrees will equal square root of 3/2. So that is one value of theta that will work. So now what I want to do is I want to figure out, how do I translate that into the fourth quadrant? And you can still use reference angles to help you figure this out. So what I want to do then is I want to reverse engineer. I know what the reference angle is that I want. I want this to be the reference angle of 30 degrees. So to reverse engineer this, I'm actually going to take 360 minus that reference angle, 30 degrees. So I've already figured what that out is, what that is. So I can just plug in the reference angle. And so the other angle that would work here would be 330 degrees. And so there are 2 values of theta that will equal square root of 3/2. It's 30 and 330 degrees. And you can use, again, that cheat sheet on reference angles to help you figure that out. I also have more examples of that in my video library. So if you're looking for a few more examples of that, be sure to check that out. And then the last thing that I want to do is I want to talk about a few other types of problems similar to this reference angles. So these are true or false problems. How do you approach these? And I want you to prove the answer. So I've got this example here that says cosine of 60, does this equal 2 times cosine of 30 degrees? So whatever we decide, I want to be able to prove it. Okay, so what I'm going to do is I'm going to reference handy chart. And I'm going to note, so cosine of 60 degrees I know is 1/2, but then also cosine of 30 degrees is square root of 3/2. So I'm going to use these 2 values and I'm just going to plug them in. So cosine of 60 we said was 1/2, and then cosine of 30 was square root of 3/2. So here's the math that's going on here. So are these 2 sides equal? They're not, right? So if I take 2 times the square root of 3/2, this just comes out to square root of 3. So these 2 sides are not equal. So this is a false statement, and this is how we prove that. And okay, so that is a pretty good breadth of different examples that come up with reference angles. So I'm going to end the video there. So if you found that helpful, consider leaving a like or a comment or sharing or subscribing. And otherwise, thanks for watching, guys. I'll catch you next time.